Okay, here we go. Not sure how the sound is going to come out here. Had some troubles on the last one. Didn't seem like it was very loud. So I apologize for that. Okay, here's part 2. Okay, and this is going to be more on graphing polar equations. Okay, so what do you suppose this would look like? R equals theta. So yeah, it's an interesting thing to think about. Well, let's just plot some points on here. Okay, and we'll make a table. Theta r. If theta is 0, r is 0. If theta is pi over 6, r is pi over 6. Pi over 4, pi over 4, pi. You see how this is working? As I go out my axes here, right? Going my normal 30, 45, 60 angles. 0 at 0, pi over 6, it's pi over 6 long, pi over 4 long, pi over 3 long, pi over 2 long, and it just keeps getting bigger and bigger all the way out to pi, and that just keeps on going. Okay, so this is just going to keep on going out like this, and it just keeps getting bigger and bigger and bigger. Okay, it makes a nice spiral. It's called the spiral of Archimedes, or the Archimedean. A-R-C-H-I-M-E-D-E, spiral. Kind of a cool little thing. Okay, but what happens when I want to graph different things? So let's look at something like this. R equals 3 sine of 2 theta. R equals 4 cosine of 3 theta. Now I'm picking these are in your book so that you can check your book on these, but we're going to do them on here as well. And then we'll look at r equals 1 plus 2 cosine of theta, and r equals 3 plus 2 cosine of theta. You can see every one of these you can make a table and go 0, r, and then just start plugging numbers in for theta, and then values for r, and then you can plot the points. Okay, so let me see if I can pull up my calculator on here and show you that. Okay, I will tell you what, for some reason I lost my calculator that's on my computer here, so I can't show that to you, so I will show that to you in class. So don't worry about graphing these, okay? But just rest assured that you can convert your calculator to polar form, and if you want to, you can look at that and go into mode and put it in polar, and you'd be able to put this in. But I want to show you that, and I apologize I don't have that on here, and I'm honestly not quite sure why it's not here. But anyway, I'll take care of that, and then we'll get back to that. But the last thing that I wanted to do is this. Let's convert the following equations, or polar equations, to rectangular form. For instance, r equals 2, or r equals 6 cosine of theta. Okay, so remember, what's the relationship between polar and rectangular? I've got r squared is x squared plus y squared. That was on the last video. Tangent of theta is y over x. And I also have x equals r cosine of theta, and y equals r sine of theta. So if r is equal to 2, I can use this guy and say, oh, well, that's the same thing as square root of x squared plus y squared, because that's what r is equal to 2. So x squared plus y squared equals 4. There's the equation of a circle centered at 0 with radius 2, and that's the same as that. Okay? Alright. What about this guy? What is, how can I rewrite that in rectangular form? I think I'm going to look at this. R, I know, is the square root of x squared plus y squared. 6, and what's the cosine of theta? Well, from here, I know the cosine of theta is x over r. So that's equal to x over r. Actually, watch this. Let's do it this way instead. What I did would work, but if I leave this as r and just write cosine of theta as x over r, if I multiply both sides by r, I get r squared equals 6x. Then r squared is x squared plus y squared equals 6x. Right? That makes it a little bit shorter, a little bit easier to do. Okay, now let's do this. Let's go the other way. Convert rectangular to polar form. So let's say, for instance, we had something like this. 2x plus 3y equals 4. Okay, well, I know that x is r cosine of theta plus 3r sine of theta, and that equals 4. And if I factor it, that's polar form, but now if I get r by itself, because we like to do that, kind of like we like to write y by itself, times 2 cosine theta plus 3 sine of theta equals 4, so then r would be 4 over 2 cosine theta plus 3 sine of theta. Okay, so that's how we can go from rectangular to polar form, by using these same equations. Okay, so try this, homework 8.3. Doesn't have any graphing problems on them. We'll do those in class. So let's have you just do 1 to 29, 1 to 29 odd, and then let's add these guys in there. 25. Oops, it's already on there. Tried the wrong one. 26. 28 and 30. Okay, so go ahead and do those, and then we'll talk about it after break. Have a great break. Again, don't worry about graphing. None of your homework problems are on graphing these guys, and we'll hit that when we get back. Otherwise, you should be good to go on these. Thanks. Have a great Thanksgiving.